All right, let's talk about something that can be a real head-scratcher, even for developers who've been at this for a while. What is actually going on with Go routines, OS threads, and the CPU threads inside your machine? If you've ever felt a bit fuzzy on how they all connect, stick around. We're about to build the one mental model that makes it all click. So let's start with the big question, the paradox that gets this whole thing started. You can write a Go program that spins up literally millions of Go routines. But your fancy, powerful computer might only have 16 cores, maybe 32 hardware threads. How on earth does that work? The numbers don't seem to add up, but they do. And the why is everything. Well, the answer to that puzzle isn't some complex magic. It actually comes down to a simple but very strict hierarchy. You see, there are 3 totally separate layers of execution, and the most important rule, the one you have to remember, is that these layers never ever mix. And here it is. This is the hierarchy. At the very bottom, you have the physical hardware, your CPU threads. Sitting on top of that is the operating system, which gives us OS threads. And then way up at the top is your Go program, which is managing all those Go routines. This top-to-bottom model is the foundation for, well, everything we're about to talk about. Okay, I know this can sound a little abstract, so to make this all just click and feel totally intuitive, we're going to use a really simple analogy for the rest of this explainer: seats, people, and tickets. This is going to be our mental shortcut to make these concepts feel solid and real. Let's start at the bottom with the metal, the CPU threads. The key thing here is that these are not a software concept. They are actual physical execution units built right into your processor. If you have an 8-core CPU with hyperthreading, you have 16 CPU threads. That number is fixed by the hardware. You can't just wish for more. So in our analogy, CPU threads are the seats. Simple as that. They represent the actual physical capacity to get work done. If your hardware gives you 16 CPU threads, then you have exactly 16 seats available for anything to run on at any single moment. No more. Now let's move one layer up to OS threads. These are different. They're a software thing, a creation of your operating system, Windows, Mac OS, Linux. And unlike the fixed number of hardware threads, the OS can create tons of these, thousands of them if it needs to. They're much more abundant than CPU threads. So if the CPU threads are the seats, what are the OS threads? Well, they're the people, right? You can have thousands of people all lined up, all wanting to do some work, but they all have to take turns and compete for one of those 16 available seats. And finally, we get to the top of our pyramid, Go routines. Now, these are super, super lightweight little tasks that are managed by the Go runtime itself, completely inside your program. The OS doesn't even know about them. And because they're so lightweight, you can create millions of them. It's no big deal. Which brings us to the final piece of our analogy. Go routines are the tickets. Think of each ticket as a specific job that needs to be done. The Go runtime is like the manager of the event, handing out these tickets to the people, ROS threads, telling them what work they need to do once they finally get a seat. Okay, let's just pause here and lock this in. A CPU thread is a seat. That's your fixed hardware limit. An OS thread is a person, managed by the operating system, waiting for a seat. And a Go routine is a ticket, a lightweight task managed by Go, which gets handed to a person. Seat, person, ticket. That's the whole model. So we have tickets, people, and seats. But what controls this whole system? Who's in charge of deciding which person gets which ticket, and, more importantly, which person actually gets to sit down in a seat? Well, that's the job of 2 totally different schedulers. Here's how it actually plays out step by step. First, the Go scheduler, which is a part of your program, looks at all its tickets, the Go routines, and hands one to a person, an OS thread. That's step 1. Then, in a completely separate action, the main boss, the operating system's scheduler, looks at all the people waiting and decides which one gets to sit in a seat, a CPU thread, and for how long. And this is absolutely crucial to understand. A Go routine doesn't just run on its own. It's basically a passenger. It's completely dependent on the OS thread it's been assigned to. So if the OS lets that thread run on the CPU, your Go routine's code runs. But if the OS decides, nope, your turn is over, and pauses that thread, your Go routine just pauses right along with it. Now, once you really get this hierarchy, it unlocks the door to understanding another huge concept. And honestly, getting this right is often what separates a junior developer from a senior one. We're talking about the real difference between parallelism and concurrency. Okay, so let's imagine a perfect world for a second. Let's say you have a machine with 16 CPU threads, and you have exactly 16 tasks you need to run. In this scenario, every single task can get its own dedicated piece of hardware to run on. Now, let's get back to reality. The scenario we started with. You've still got those same 16 CPU threads, but now you have a million tasks, a million Go routines that are all trying to get some work done. And these two examples perfectly illustrate the difference. Parallelism, like in that first example, is when you are literally doing multiple things at the exact same time because you have enough hardware to go around. Concurrency, which is our second example, is about making progress on many things. The system just switches between tasks so incredibly fast that it looks like they're all happening at once, even though at any given nanosecond, only 16 are actually executing. Whew, okay, we've gone through a lot. But what if you had to boil this entire powerful concept down to its absolute core? Let's take a moment and just crystallize this whole mental model into a single, perfect summary. If you remember only one thing from our time together, please make it this sentence. Go schedules Go routines onto OS threads, and the OS schedules OS threads onto CPU threads. That's it. That's the whole game, the complete, correct model right there. And look, if you ever need to explain this in a job interview or just to a teammate, here is the perfect, bite-sized way to say it. It shows you get the different layers, you know who's in charge of what, and you understand that fundamental hardware limit. So let's just take a step back and appreciate what you now understand with total clarity. You get the difference between these three layers. You know the true meaning of parallelism versus concurrency. You get the two-scheduler system, and you can now confidently explain both why a million Go routines is totally possible and why your CPU's physical limits are still the ultimate boss. That's a senior-level understanding.